Okay, so in equation 84, we just show you how to evaluate W raised to the power P1. According to the previous slide, W raised to the power P1 is the same thing as W raised to the power as indicated on the right hand side of equation 84. Now, with that, we can begin to do a little bit more expansion. For example, we can take the first term of the parenthesis and then multiply with K2, R2, R3. When we do that, this is what we get as indicated in the red color, power. Similarly, if we take the second term of the parenthesis, which is N1 times R1, and multiply with K2, R2, R3, then you will get the second power, which is shown right here as indicated in the green color. And finally, if you take the last term of the first parenthesis, which is N0, and we multiply with K2, R2, R3, shown in the blue color, then you get that power right there. So now we notice a couple of things. What I said is any term that I show you inside the square bracket, like this term, like that term inside the square bracket, I can prove to you that they're all equal to 1. In other words, this term is equal to 1, and that term is equal to 1. And we can prove it very easily by making use of the definition of W together with Euler identity. In case you forgot, let me try to help you a little bit. Like, for example, how do we prove that this term here is equal to 1? Well, first, the definition of W is what? W is defined as E raised to the power minus I times 2 pi divided by capital N. But don't forget, in this case, capital N is equal to the product of R1 times R2 times R3. So that is the definition of W. If you take that definition of W and then you raise it to this power, okay, then you have to take that definition raised to the power of the same thing, which is N2 R1 R2 R1 R2 times K2 R2 R3 K2 R2 R3. Then you will see it turn out to be equal to this. First, you recognize R1, R2, R3 that you have in this denominator here. You can cancel with R1, R2, R3 with that one over there. So the equation I just wrote for you over there now become simply E raised to the power minus I 2 pi, the whole thing, raised to the power N2, K2, and R2. Okay? And then we can prove to you very easily that this term right here is equal to 1 because of the so-called Euler identity. That term is equal to 1. And that term is equal to 1. It means if you raise 1 to any power, such as power of N2, K2, R2, the whole thing is also equal to 1. So I already proved to you. And using the same proof, we can say that the second square bracket that you see in here is also equal to 1. And therefore, the computation of W raised to the power P1 is simply equal to, as indicated in equation 85. All you have left on the right hand side is just W raised to that power, which is come from here. Okay? So, to make a conclusion, W raised to the power P1 can be simplified to something like indicated in equation 85. Similarly, equation 86 that you see on the screen basically compute W raised to the power P2. Well, in this case, P2 is the power that you see on the red color in equation 86. And again, using the same technique, what you can do, you can take the first term of the first parenthesis and then you multiply with K1R3. This is the first term of the first parenthesis. You multiply with K1R3 as I show you in the blue color. Also, you have the remaining term of the first parenthesis multiply with K1R3. That is shown as the first term, the remaining term of the first parenthesis times K1R3. And then we can prove to you again that the thing inside the square bracket term right here, that is equal to 1. That is equal to 1. We can prove to you that this term is equal to 1 using the same idea like I just explained to you on the previous slide. Therefore, W raised to the power P2 right here is equal, the right hand side just equal to this remaining term for W as indicated in equation 87. Equation 87. And similarly, we can compute W raised to the power 3 as shown in equation 88. Equation 88. So, after we calculate W raised to the power P1, W raised to the power P2, W raised to the power P3, the next thing we say, remember, W raised to the power P is the same thing as W raised to the power P1 times W raised to the power P2 times W raised to the power P3. So W raised to the power P1, that is this term right there in red color. W raised to the power P2, that is this term right here in the green color. W raised to the power P3, that is this term right here in equation 89 as I show you in the blue color. And I hope you remember I said many times that you will have a formula earlier. C tilde is a function of n is equal to the summation on the index k of f of k times W raised to the power nk. That formula that I wrote it down in the green color, it came from much earlier chapter when we talk about informal development of the fast Fourier transform. Now, all you have to do is just replace the index n, small n, in terms of the small index n2, n1, n0. And then a summation on the index k now become the summation on the three index k0, k1, and k2. F expressed in terms of k now become f expressed in terms of k2, k1, k0. And finally, W raised to the power small n, that small n now is expressed as this term right here. This W raised to the power nk, that term is right here, corresponding to this term right there. So this is what you have for equation 89, okay, where W raised to the power nk, based on the informal development of fast Fourier transform, that term is shown you in here in the blue color. So the computational procedure basically go like this. First,